All right, so what I want to talk about today is testing. And the first thing I'm going to launch is Excel. It doesn't have to be Excel. You could even do this in Word if you wanted. But I'm just going to bring up an empty spreadsheet. I'm going to make it a lot bigger. Okay, so what we're going to do is create kind of a test worksheet. Have any of you ever done any software testing? You have, yeah. What kinds of things do you put? Do you keep? You probably keep a track of your tests, right? Do you use a software that keeps track of your tests, or?
Yeah, we just use the software. And even when I was testing at Nintendo and Microsoft, we just kept Excel sheets of what we need to test.
Right, but that's kind of what I want to start is create an Excel sheet of what we want to test. So first of all, I'm going to just kind of figure out what the topics are. Then I'm going to make a class, and we'll talk about what we would test. And then I want to show you unit tests in Visual Studio. So I would do, I'm just going to put the class that we would test. All right. And then I'm going to do like the date of the test, probably the time too. There are, if you're actually doing this professionally or going in, there are people that are hired just to test software. They'll give you a list of tests to do, and there is software that will track what you do, right, and record the results. But if you ever have to do it manually, we're going to do that. What kinds of things? So I'm saying what class? I mean, in the program, what class are we? Do these belong? I'm going to. What method are we testing in the class? What else do you think you would need to know?
Is that should that be on 3A?
Why? No, I'm going to go across. You could go down. It doesn't matter. Anybody? What would you else need to know? When you're writing a program, what are the key core elements of any program, any method? Think way back to ITC 110. Variables. Well, the input and output. Variables store input and output, right? So I'm going to do the input here. What is coming into the method? And that could come in through parameters or inputted values. This could be broken up. All of these could be more complex, just to let you know. So the output, I'm going to break into two parts because we're testing. I'm going to say expected output, and then I'm going to put the actual output. Now, 99% of the time, if you've done your job, those are the same, right? And then I might put something like, I don't know, do you guys do like notes as an option? So what happens if the actual output isn't the same as the expected output?
We use nodes as an option.
Is there anything else big that I'm forgetting that we should do as we go through these tests? So the method would be what method we're testing. The input is what data is coming into that, either through parameters or variable values, things like that. And again, that could be broken out if you want to be real specific. What does the expected output of the method when you run it? If you run the method with those numbers or with those inputs, what do you expect the result to be, right? Typically, like we're going to do like a tip class because it's my go-to class for any time I want to show things. If you have $100 and you're tipping 20%, what should the tip be? $20, right? So that's what you would expect the output to be. One of the things when doing this is you should use values that are pretty easy to tell if they're right or wrong. And then if the actual output is $20, then you know you're good. If it's different than $20, you know you're not good. And then you need to figure out why. All right. So does that make sense? for the groups, before I go in, basically what we're going to do is look at what you guys have, the classes and stuff that you wrote, and just come through with a set of ways you want to test it. We're going to talk about ways to test it. I'm not going to actually ask you to do the actual output. You can do it if you want, but most of your things aren't that functional. So I mainly just want to know, what would you test? Not necessarily how do you conduct the test. As I said, you can if you want, but you aren't required to. With the personal one, we actually are going to conduct the test. But all right, so we'll leave this up because this is going to be our test thing. And then what I'm going to do is create a class, and then we can talk about what tests we would want to do. And then I'll show you how in Visual Studio you can conduct those tests. You could also do it in Eclipse if you were to write it in Java, because Eclipse, they have testing libraries too, right? Unit test libraries. I haven't used them much. That's why I'm doing this one. But okay. So I'm going to launch Visual Studio. And we're going to make just a simple, I'll zoom on this. We're just going to make a simple console app. And it's going to have one class. So I'm going to do File, New Project. It's going to be a C# project, and it's going to be a console app. Okay. You guys don't have to do this, but if you wanted to.
The framework not before.
Yes. And I'm going to call it, what do I want to call it? It's going to just do tips. Call it tips.
I didn't get that.
What?
Oh.
I did File, New Project, Visual C#, Console App.
Ah, I see.
Console apps are boring, but they're fast. Typically, when you're writing, you only write console apps for like utilities and things that run in the background. Or when you're learning how to program, because then you don't have to deal with all the forms and stuff. So I'm just going to call it tips, and I'm going to do OK. And it's going to give me basically this. It's going to give me the static void main where the program would start. That makes sense. And we're actually going to ignore this. For unit testing, the program doesn't have to run. Though I could run it if you want. Over here, there's a Solution Explorer. The Solution Explorer is a list of all the files that are in your project. Right now, we have program. So I'm going to add another class to this. I'm just going to right-click. I'm going to add, and I'm going to add a class. You don't have to do it this way. I always right-click, go here and do this. You can also get it from the project file. So the other way to do this, if you prefer, is to go to Project, Add Class. So it's actually fewer steps.
Mine's gray.
Yours is gray. Mm-hmm. What did you do for the project? Looks like it's okay. Should be able to right-click after that. Add class. Add. I think it would have done it. So when I add the class, let me go back to the other one. It doesn't matter which way you do it, as I said. I'm going to name it, I named the project tips. This is kind of, I probably should name it something different, but I'll name it tip. Could name it tip calculator, I suppose. You guys have a preference? And I want the dot back in there, or it'll be tipcs.cs. All right, so I'm just going to add it. And it gives me an empty class. The namespace is like the package in Java, if you guys have done Java. So it's what groups things together. So I'm going to do, I'm just going to walk through this class. I'm not going to make it real complicated right now. We'll add a little bit later as we test it. But I don't want to spend all my time coding in front of you for this. The point is the testing more. So what kind of fields does this need? What?
Bill amount.
Yeah, so we need something. I'm going to cheat a little. I'm just going to do public. I guess let's double. So let's do bill amount. The thing that I'm cheating is I'm going to do the get set. I'm using a Microsoft shortcut rather than writing my getters and setters. It has the same effect. It's actually doing that underneath. It's just in the compiler, it creates gets and sets and things. So. It's a whole lot easier. But you could. It's also possible. It'll do just like Java. If you just do a without the get and set there, if you mouse over it, it'll create the getters and setters for you. Right? Or this is the shortcut for getters and setters. If you're not doing anything in the getters and setters other than the normal gets and sets. And then I'm going to do public. What else do we need? Yeah, so we need the tip percent. And I'm going to add the tax percent. Usually when you get a bill, it's it gives you the total, the amount, the tip, the tax, and then the total. This could be, I mean, I've actually built this tip class. I've built it in Java. I've built it in Python. I've built it in Android. I made an app that'll calculate tips, and then you could add, if you wanted, you could do all sorts of social media things. What's an appropriate tip for this service and all sorts of things. And you could build it out quite a bit, but we're not going to. I'm going to do a couple of methods. So one is calculate, I'm going to use Microsoft's tip, and I'm just going to, these are going to be real simple. I'm going to just return bill amount times tip percent. We may adjust this later because there are some inherent difficulties here, but we'll skip that. And then I'm going to do public double calculate tax. And no semicolon there. I'm just going to return bill amount times tax percent. And then the very last one will be public. I keep wanting to capitalize public. Double calculate total. There's multiple ways you could do this. I'm assuming you use the getters and the setters, so all those things have value. You could also pass them in as parameters, right? So, but I'm going to do return. So I'm going to do bill amount plus calculate tip plus calculate tax. Now, I'm not going to use this class. If I were to do that, I think I would also create a toString or something that would put this out in a nice receipt, right? But I just want to test these things. So how would we, what are some of the tests that you would do for calculate tip? If I go back down to the spreadsheet. So we've got the class will be tips or tip, the date, whatever. Is there a quick way in Excel to enter the current date? I know there is, I just don't know what it is. Hey, thank you. I used to know Excel really well, but I don't use it anymore at all. I should probably learn it again more. I don't know. So the method is calculate tip. So what do we want to test? What different inputs might we test? What would be an easy one?
100.
All right, so let's say amount, I don't know how we want to enter it. Let's say it's 100. Tip percent. Let's see, I'm going to put wrap text. I'm going to do 0.20. So the expected output would be would be 20, right? So if we have 100 and we do the output is 20%, it should be 20. Notice that's 0.20. One of the things that we should probably also do is, and I'm going to do the same calculate tip. What happens if accepted instead of 0.20, it's 20? What if they enter 20 for 20%? It would, it would enter 200 probably, but we want to. That's something we maybe need to adjust, right? What other tests can you think of that you might want to do on that?
Zero.
Yeah, what happens if we do 0?
Error.
Shouldn't be. Huh. Doesn't keep it. If the tip percent is 0, what should the result be? It should be 0. Yeah. We're not dividing by 0, so there shouldn't be any real issue with 0. What other kinds of possible entries would there be?
Empty.
It could be empty, right? So you might be what happens if you don't enter a value? One of the things you might do is what happens if you if amount was 0 and tip, the result should be 0, right? whatever, because it's just 0. This should be 0. That's an O. And I'm going to do one more. I'm not dating these right now. Where let's say the amount is null. And then the tip is whatever. What happens when you multiply a null? Now, actually, so it's really hard to set it as a null. Because by default, if you don't create a constructor, they automatically are assigned 0. Right? They're assigned the lowest value. A string is assigned null, but numeric value is assigned 0 by default. So it would be hard to make it a null. One other thing I'll do, one extra thing. This could cause
Negative maybe?
what?
Negative.
Yeah, you could do a negative. So
Amount 100%.
so if we did the amount as 100, I've changed my pattern here, which isn't good. Tip minus. Would that be minus $20 then? That would not make sense either, would it? This should actually be, null should throw an error, but I'm not sure we could even get it to do that. This won't throw an error. It'll just give us minus 20 as the expected result. Is there anything else that we would test? Here's the last one I would test. And that should result in an error also. And that's actually a hard error to prevent. I mean, it's you couldn't handle it with a try-catch. You'd have to do something else. So we have lots of different tests, right? This is just for the first method. But one of the things you want to do is like test all the different things. And then what I'm going to do in just a second is we'll go in and we'll actually try these tests and see what we get. Does that make sense? And then we may make a couple of adjustments to the class and maybe test a couple of the last two methods a little bit. But this is sort of what testing consists of, looking for every possible input, looking for all the possible configurations of how they come out, and making sure that you can handle those, right? Particularly with form inputs and stuff, anytime you open a text box to a user, you're making a potential for getting real garbage in, right? So how do you handle their garbage without crashing your program? You know, and how do you handle legitimate errors too? I mean, what kinds of errors can happen? It's also really good to check to make sure your math is correct. Our math is really simple, but if your math isn't simple, the chance of an error is greater. And some problems, I wish I remembered. I used to have an example in mind, but I can't think of it now. Sometimes the problem will come out and it will look reasonable, but it'll be off by a few, decimal points. And the bigger the number, the larger the decimal error, until it starts to become truly significant. Those are the hardest to match, right? Because then they're within, they look reasonable until they expand to a certain point, a certain threshold, they start to get really bad. All right, so we've got these. So let's go in. I'm just going to copy these down. Didn't need that there. Doesn't matter. I was just trying to. I quit. All right. I quit word wrapping and started just using alternate rows. It would be good to be consistent if you're going to do that. All right, so I'm going to minimize this. All right, so we have our tip here. So how do you create a test for this? And this part will vary a little bit depending on what platform you're in. In Visual Studio, the way that you create a tip or a unit test is you go up to the solution and you right click and you want to add a project. So I'm going to add a new project because it's a separate project under the solution. And what we want to do is we want to go under test, unit test project. So these are built in, what they'll do is they'll help you test every method, and we can walk through a lot of these. So I'm going to add that. We can test, name it whatever you want. I'm going to leave it as unit test project 1 because I don't care too much. All right. So over here, we've got tips, and now we've got unit test project 1. The unit test, if I go over here, it gives us a test class, gives us a test method, and then an empty test method. A couple of things we have to do is we have to attach this test project to the other one so it can see what's in there. Actually, real quickly, I'm going to change class. I always forget this. For some reason, when you just do it, it doesn't make it public. And if you don't make it public, you're not going to see it in your test. All right, but I'm going to do a thing on the test. I'm going to right-click on the test project. I am going to add a reference. And I could take you through this again. We'll do this in a minute, but I'm adding a reference. And the reference I'm going to add is going to be to tips as projects. If you go to like COM or Browse, so COM has the most, there are tons of libraries that Visual Studio isn't using that you can add, but we want projects. Same with assemblies. Tons of libraries that are part of the .NET framework that aren't being used in this project. But if we go to projects, there it has tips, and I'm just going to click on tips. So there's a reference now to tips. And up here, this is just for convenience. I'm going to say using tips. And that way I don't have to refer to that namespace. I could just say what I'm doing, and it just saves me some typing later. Using means I'm using that project as a part of the reference for this. Does that make sense, sort of? There are things like if you did the 172, we knew using the application models, or using if you wanted to do some kind of encryption, there's a system.encryption library. You know, there are lots of different things you can do. With the it's like an include in Java. So I am going to right up here. I'm going to say tip t equals new tip, and that references my tip class. All right, so we're going to test, and let's do, this is test method 1, but I'm going to rename it. What do we want to name it? So it's for this first test. I mean, we could use the same one over and over again, but we could make lots of them too. I guess let's do a calculate tip. We'll just use the same one over. Although typically in real life you wouldn't do that. You would make a different method for each of them so that you'd have documentation basically. So calc tip test. All right. So in here, I'm going to just hard code some amounts. So I'm going to do t dot bill amount equals 100, right? So we're going to do that 100. T tip percent equals, this time we're going to do 0.20. And then that's actually all we need, right? No, not for this one because we're just testing the calculate tip. So I'm going to do t dot, so I'm going to actually create a double tip amount equals, and I'll capitalize that, t dot calculate tip. So we've given values, the values that we said we're going to test there. We're calling the method to see if it'll work, and we were assigning it to a thing. So what I'm going to say here, and this is a word you probably haven't seen, but I'm going to assert. I am going to assert the two things are equal. I am going to assert that tip amount is equal to 20. Oops, comma there. Tip amount is equal to 20. There are other things besides are equal. You could say are not equal, or greater than, or that one's true or false. If you do the dot here after assert, there's a whole list of things you can assert. So we have this, and I'm going to run the test. So I'm going to do test run. I'm going to run all the tests, although there's only one. And it should give me a true. So test passed. See how it has check marks? You know, the test passed. Now, if I change this to, say, 25, particularly since I'm just putting a literal value in there, if I run it again, so test run all tests, I'm going to get red X's because the test failed. And if I click on this and go down here, it'll tell me why it failed. Basically, it'll tell me that R equal failed, expected 20, actual 25. So this seems like it's wrong in terms of what is expected, but the actual should be 20 and the expected is 25. But whatever. For what? Let's see if this close tip equals new tip. Is that what? Go back to your tips. Tip class. Change that public. All right, let's go back. Doesn't work. Did you do it as lowercase t in the other one? All right, so, and again, if I change it to 20. So I change it back. It's interesting. It was doing this automatically for me without having to run the test last time. Now it's back to green. If we change it to 200, I mean, if we change it, take the period out of it. We might have said that we expected 20. We were smart enough to know that that wouldn't be the case, but that would fail because it would be, oh, I ran it. That's not what I want to do. I want to do test run. And it will fail because that's not what we're going to get. So in the spreadsheet, on the first one, 20, so that passed. If you want to note, you could just say passed. This one, actually, we said 200. 200 is what we would get. But we want to change this. Right? We'd want to change that. I know that's way too big when it's zoomed. How would we change it in the class? Do anybody know? Let's go back to tip. Notice that it has pass. It has the failure right now because it failed. So in the class itself, it reflects the failures of the passing of the test too. I'm just going to write here if tip percent. Do we want to say that 100% is the biggest tip possible? I mean, there are people that tip more than 100%. But I'm going to say if the tip is greater than 1, then 10%. Should work. Divide equal is the same as saying tip percent equals tip percent divided by 100. So we made that change. Let's go back to our unit tests. I'm not going to do this all day, but I'll just give you some examples. We'll do a couple of other tests too. So now if we enter 20, the result should be 20. So I'm going to not start. I keep wanting to do that. I'm going to run all tests. And now it's green again. So it succeeded. So you could enter the tip as 20 or as 0.20. Just to confirm that, make sure that it doesn't screw up 0.20. It actually did it this time. It ran it. It ran it without me asking it to run it. I guess it just takes it a while. Because it just went green on that. If I run it, the test, it'll have the same result. But I don't think I have to run it directly anymore. So it works both ways. And we could reflect that in our sheet. So now we can say that the expected output should be 20. Although probably rather than change the existing, you should probably create a new test. And then the expected answer this time should be 20. And the note, the actual response is 20. And basically document that method was changed. And you might be more specific about that too. Does that make sense? All right. let's test a couple of the others just real quickly. I'm not going to go through all the tests, but just um, the other thing is, as a testing method, I've been just changing these values here. It might be good to have a separate method for each test. If you wanted the methods itself to document to some extent. So I'm going to add test method. You have to have this up here. It's a compiler directive, and it's not a text method, but a test method. It tells it that to treat it as a test method. If you don't have that in the square brackets above it, it won't. You can write a method, but it just won't work. Right? So let's test. Tax is the same as this one. Let's test the basically we'll test the total. All right, so actually these are declared. I don't think it'll see those, but it might because it's declared up here. It has, so we should be able to do that and then just do add t dot. We'll see if this works. Tax percent equals 0.09, although we have some of the same issues with taxes, right? If I entered it as a whole number, we're going to be really intensely taxed. I'm going to do tax amount, and I need to give it a type. Equals calculate t dot. Calculate tax. And there are better ways to set this up, by the way. Double total equals t dot calculate total. I'm assuming that it remembers these. If it doesn't, we'll see it. So if we do so I need not that, I need assert r equal. What actually there's a more efficient way to do this, but I'll show you in a minute. What would the total be if everything calculates? So there'd be 120 plus 9, so 129. I'm not sure about the points. Let's see if that works. So I'm going to test all again. So I'm going to do test run all tests. And that came out wrong. That didn't work. So what did I get? So the failed one.
You don't get a new amount.
I didn't get the amounts. These didn't come through. So I'm going to just copy those down. There's a more efficient way to do this, but so now if I run the tests again, now they both pass. One of the things you could do if you didn't want to do total here, If you want it to be slightly more efficient, this would have the same effect. And it would result in the same. Run all tests. They're both passed. This would have the same problem with the tax percent, right? Because if I were to take that out, if I were to say it was a 9% tax, it would fail, and it's 1,020 as opposed to because it's the amount plus it's the amount times 9 plus the tax. So we could fix that. So I think I've shown you. Does that make sense? With the group project, again, let me unzoom for this. The group project, all I really want is you to think through what the tests would be for your what you guys kind of wrote, right? What the methods would be. Just think through what kinds of things you'd want to test. We didn't test. One of the things we didn't test is the percent. So where you put in the percent sign, that was there. This would fail, I know. It would generate an error. Okay, and all you have to do is what you think the result would be. You don't have to run them unless you're just feeling ambitious. Let me show you, though, for the personal one. This one's a little more complicated. So, are you guys ready? Then I'll let you guys work on stuff or go. All right, so and I haven't loaded this. So I need to load Canvas. I wonder if I should put this up on GitHub. I don't think I have a version of this on GitHub. Boy, that's big. I'm still zoomed. Let's go to 255, wherever that is. There it is. Under Files, go. There is a fraction class. Let's see if I can find it.
Wait. The T one. The T. Yes, the highlighted.
Oh, it went right there. I would probably, you might be able to just copy it from here. I'm a little leery of that. I will see if it works. It's not important that you understand the code. I will show you how it works. All right, so I'm going to start a brand new project. File, new project. And it will be not a unit test, but a console app. And I can zoom up for this, I guess. I'm just going to call it fraction math. You can call it whatever you want. I'm going to do OK. All right. Why did it give me hello world? What did I do? It was just console, right?
The .NET Core gives you the hello world.
I meant to do, it's probably okay. Let me do it again. I was thinking of just the .NET framework. I'll call it fraction math 2. The only thing is I'm not sure if there might be something unfamiliar there. I'm going to add a class to this. And the class I'm going to call just fraction with a capital F. I'm going to add. And I am going to paste. Now, I do need to change one thing at the very top, which is the namespace. So instead of fractions, I'm going to call this, my namespace was fraction math 2. And I'm going to get rid of these. And I'm going to make this a public class. With a lowercase p. Not sure why I want to capitalize. So, as I said, you do not need to understand the coding here. I'm not asking you to fix anything or anything. There are a couple of errors that I coded in on purpose so that if you do testing, there are things you can find. But mostly what it does is it creates a fraction. Again, this is going a little bit from, has several different constructors. Why doesn't it like exception? Oh, I think I may know what the problem is. Do I have that problem elsewhere? I would advise you not to copy it like I did from Canvas. I would download it and then copy it in from Notepad or something. It's not liking that and that. Oh, and that's the other thing. Line break. That's actually what the error is. The line break is the error. Is there anything else in here before? I'm just looking for other. Yeah, annotations doesn't belong in there. I think that's it. I think that'll work. I will test it by compiling it. Build solution. It succeeded, so it's okay. So, as I said, I'm not expecting you to understand the code at all. I would consider this to be kind of advanced C#. And since you probably haven't really had C#, it will. Yeah, but let me show you how it works. So I'm going to go over to the program. And I am going to just initialize the fraction. I'm going to say fraction f. I'm going to say fraction f equals new fraction, and I'm going to use one of the constructors, and I'm going to say 1/3. And then I'm going to do fraction f2 equals new fraction. What do we want in there? 1/2? Okay, and then I'm going to say fraction f3 equals f1 plus f2. And then I'm going to print, actually that's console, right line, f3 toString. And what that'll do is it'll give me the result. So actually I'll do a little bit. F1 toString plus I have to concatenate this. Probably a better way to do this actually right now, but I'll do it this way. F2 toString, and that means a parent. Let me kind of break that down. So this one I would do equals F3 toString, and then I need a plus and a plus, and then a semicolon. All right, so if we run this, oops. It's been a while since I've taught C# too. Wait key isn't right. I need something to wait on something. Read key will work. All right, so if I run this, and then if I zoom that way up, you can see that 2/6 plus 3/6 equals 5/6. One of the things that it did, notice I had 1/3 in there, but it changed the denominators to a common denominator. Right, so 2 times 3 is 6. 1/6 and 3/6. And if I were to do another one, if I were to do a multiplication, so what I'm going to do is the same two fractions. Let's zoom down. I will just do oh, how do I want to do this? I have to do it after I print that. I'll do fraction f4, let's do it this way, equals f1 times f2. And I'll do the console. And I'll just change this to f4 and this to a multiplication. And if I run it again, it does 2/6 times 3/6 equals 1/6. Is that correct? So it's 2 times 3 is 6, right? So 6 over 6. Should be 6 over 6. It's reversed. It's wrong. Is it 6 over? Yeah, 6 over 36. That is correct. It is correct. My math has gone downhill since I did this. So that's sort of how it works. The other can say, I'm going to do one other little thing. If let's do if F1 is greater than, there's a Boolean for these. If F1 is greater than F2, what do we want to do with that? Console right line F1 to string plus. Now you're not going to have to do any of this stuff, right? I'm just trying to show you how it works. And then I'm going to say and we'll add a test in a moment. We'll do like one test. And then I'm just going to do this, except that it's else if instead of if else. If else.
Oh, I think you pasted out of the class, out of my phone.
I did indeed. Thank you. No, it's else if. Is it just one word? No, it doesn't like else if. It was right the first time. Oh, and this is why. And then I'm just going to do else. So it overrides, my class does not only the multiplication, division, addition, subtraction, it does comparisons, greater than, equal, less than, greater than, equal to, all of those things. So what I want to do is get this out of the way. So I will run it again. Build errors. What did I? Oh, semicolon. It actually didn't do that. Why? Oh, it did. No, those are the times in the multiplication. Why does it not do? Oh, this only will do this. Well, else if. Else, that actually should work. Why is it not doing that part? Oh, because of the read key.
Oh.
Yeah, all right. All right. I just want to kill it then. The read key is in the wrong place. Okay, and this is the last I'm going to do for a demo. I just wanted to show you because these are booleans. A boolean is if it's greater than, that's true. Otherwise, it's false. When you do tests, I'm going to show you just a couple of quick tests on it in a moment. So it's greater than 2.6 is greater than 3.6. Is that right?
No, I think you forgot to change.
I forgot to change the sign. Yeah, okay. Let's change the sign. Yes, they're both the same. You have a good, you're keeping track. All right, so that's better. Couple of things. There are some errors in this. A couple that I've programmed, and I think there's a couple that are just right because I screwed up. And if you find any, that's fine. I'm not asking you to spend hours at this, but let's do a tiny, just set up a test one so you can sort of see how to do it. If you are really interested in the fraction class, you're welcome to look through it. It's fairly thoroughly commented. But as I said, it's stuff that, it's like you're overwriting the equal operator, takes in two fractions as an argument, and then it talks about what qualifies as making them equal, right? And so you have to tell it for the numerator and the denominator. Every fraction has a numerator and a denominator thing. There are several different constructors. There's an empty constructor. There's one that takes in the numerator and denominator as ints. I don't have ways of handling mixed numbers in here. I mean, mixed fractions. So, but anyway, and then there's where it takes in a string and parses the string out to a fraction. And then there's one that takes in a fraction as an argument. It was fun. It's actually one of the more sophisticated things I ever wrote, even though it has some problems. All right, so let's set up a test. So again, what you want to do is on the solution level, and I'll help you with this. And the first part is to figure out what kinds of things you want to test. Right? What would you be testing on this? If you wanted to make sure the fraction class was good before you gave it to your third grade kids to use, what would be some of the things you'd test? Well, you want to make sure that it does the math right? You'd want to make sure that the plus gives you a correct answer, that the minus gives you a correct answer, that the time, multiplication gives you the correct answer, division as well, and you might want to check the comparison operators to make sure that it's actually accurate, which is greater than, less than, which is, is it true when they're equal? This does reduce fractions, so that's another thing you could test if you really wanted to test, is whether it reduced things properly. I'm going down after all the operators. That's to string. This is my method for reducing a fraction. There's a greatest common denominator. Instead of doing the least common denominator, I always just do the greatest common denominator. It works just as well, but it's clumsy if you were to do it while handwriting it. Basically, I always just multiply the denominators. And then we can reduce it. The reduction goes through and reduces it. The what? It should throw us. I think that's actually something to test. It's been a long time since I wrote this. I think I might have put an error trap in that for that, but I'm not sure. So one would be to check these are the things that it does. It does plus minus division, equality, not equal, equals in the sense of like the string equals, less than, greater than, less than or equal to, and things like this. Greater than or equal to or less than or equal to. So let's do a test anyway. We'll just do two tests to show you the way, and then I will call this good. I'm not expecting you to get started on it today. This is the last assignment, I think, except for if I get the final done. So we're ahead of schedule. So let's do add new project. Okay, and we want to test project. So we go down to test, unit tests, Again, I don't care what it's named. Unit test project 1 is good. And then I'm going to, on the unit test project, I'm going to right click, add reference. And we need to add a reference to the one that we want to test. And I'm going to do OK. I'm going to put a using statement for fraction math 2. That wouldn't have come up without making the reference. Okay. And then test method. What do we want to test? Test addition. This is going to test my fraction math ability. So one of the things, if you were really doing this, and I don't necessarily mean for you to go through this, when you do fraction math, what are the things that could come up? So if you do 3/4 plus 1/4, what would that be?
1.
It would be 1. So it'd be 4/4 or 1. I don't think I reduce ones. That's maybe another error. I think it would come out as 4/4. So that's one of the things you could look at. If you do like 3/2 and 1/4, well, actually, let's do 1/4. 1/2 and 1/4. That would be, you'd want to turn this to 4, right? And this would be 2, so it should equals 3/4. Let's do that one because that's fairly easy. I remember fractions have always, they give most people that aren't good at math problems. They've always sort of given me problems. I think that's one reason I wrote the class initially. And I wrote it way back when my daughter was in like the 3rd grade. And she is now 22 years old. So that's, if I have memory lapses as to what's in here, that's one reason. So let's do fraction. Fraction F1 equals new fraction. The other thing you might want to test if you were being real thorough is what the 3 different constructors. So one of the constructors that I could do, and I wouldn't test them all in the same thing, but one constructor is I'm going to do 1, 2. That is one constructor. I'm going to do fraction F2 equals new fraction. And I could do this as 1/4. So that's a different constructor where you can enter it as a fraction string. You could also use the empty constructor and then just assign the denominator and numerator. All right, so let's assert that F1 plus F2, and it's going to result in 3/4, right? And it will return a string. Oh, so actually, I think I have to do the fraction. I have to do fraction F3 equals F1 plus F2, and then because we need to do F3 to, this should be 3, 2 string, because it's the 2 string that gives out the result, and it will return it like this. Oh, and it's resert R equal. So let's try that test. And that passed. So it did actually, that worked. And then I want to just show like the equal sign, just our greater than, less than. So I'm going to do another test, and I'll post these. Let's do test. I'm going to say comparative. And instead of doing, I'm going to say that F1 is greater than F2, which is correct. And instead of R equal, actually, so I think I can do this. Let's do this. I'm going to do F1 greater than F2, and I'm going to say as a result that that should be true. But instead of R equal, actually, I may not even need the true. I just want to say is true. And then I think it just has one argument. So let's see if that works. Test, run, all tests. Has it done? Oh, you know why this didn't run?
Oh, the test method.
I don't have the test method over it. Okay, so let's try it now. Test. Notice it says not run over here now. Run all tests, and it passed also. So that's true. So is true. There's also is false, if you wanted to test if something was false. I just wanted to show you that there's different arguments in that. So there's two of your tests. And when you're doing this assignment, just do whatever. I think what I would do is think about, it's more important for me, probably when you're doing this, to come up with a good list of tests, but you don't necessarily have to do all of them, right? Just do a couple, 3 of them. Maybe a few more than 3, but just a few of them. You could probably come up with 40 tests. And I'm not going to make you write out all those. Although you've got time, right? And I'll help you set that up if you need. I'll post this. Do you want me to put the fraction class on GitHub? Would that make it easier for to get it than from files?
Sure, why not?
Yeah. I don't know. I wonder if I can get everything up on, including the test thing on GitHub from right here. Let me unzip. I'm going to kill the video now too. So I will give you time. You're going to have today and, let's get that zoom out of there.